All right, today we are back with our last lesson of this topic, topic 2. I like to move it. We're going to be talking about transformations of exponentials and logarithmic functions. We're moving graphs up, down, left, right, flipping them, shifting them, all that fun stuff, stretching them, all those fun things. That's what we're going to be doing today. That is a review. Now, some of you still need help with that, but it is review. It's exactly the same shifts and transformations and translations that we've done the whole time. All right, so let's quickly get into it. All right, the first thing I want to talk about here is let's look at our review. Let's do one real quick. Determine the inverse, so I'm going to make this x, and I'm going to make this y. All right, now I can rewrite that as a log, right? Log base 2 of x equals y. All right, y equals 7, or excuse me, x equals 7 to the y. Log base 7 of x equals y. Easy peasy. Same thing over here. X equals log 4 of y. Now I'm going to rewrite this one as an exponent. So base 4 to the x power equals y. I know, my y's and 4's look a lot alike. All right, sorry about that. So x equals log. Now I'm going to write base 10 of y. So now I know that's 10 to the x equals y. Remember, if it's not written, it's a common log, and that common log is 10. All right, let's get into it. So we're going to match these graphs over here, all right, with these. So let's take the basic one right here and talk about it. It's an exponential function. That means it's going to go up and get bigger as I go because it is a positive. That means it's greater than 1, so it's going to increase. All right, so I know that function is b, so this is 10 to the x. Let's go to the next one. All right, this has a negative. Remember, anytime we have a negative, it's a flip, a reflection. All right, that negative is on the inside. Anything on the inside is horizontal. So I have one negative flip on the inside. So I'm going to take this picture and flip it. So it should look like that. That would be d. So that is 10 to the negative x. All right, so now we got that one. Let's do the next one. This is a negative on the outside. Remember, outside are vertical flips. So that is going to take my base 1 and flip it upside down, much like a right here, a. So this will be negative 10 to the, oh no, that's not that flipped upside down, is it? This one would be that flipped upside down. Excuse me, negative 10 to the x. This one is actually flipped upside down and then flipped, two flips. So that is why it's a flip of vertical and a horizontal flip. So this would be negative 10 to the negative x. Awesome. All right, now we're going to do the same thing with, on page 607, with our logs. Log base 2. Remember, a log has a vertical asymptote, so it approaches something and then it slowly rises and goes much further that way. So if this is log base 2, this is going to be here. So log base 2 of x. Let's see, this one is a negative, so that's on the outside, so it's going to take this and flip it up. All right, if this flips up, all right, remember this is going like this. Which one would that be? That looks like this right here, right? So negative log of 2 to the x. All right. This is flipping it horizontally, so instead of it going like this, it should go the other way, like in here. So that would be d, right? Log base 2 of negative x. It's on the inside. And then our last, we have a flip and a flip. So I flip this one, and then I flip it again here. This would be a negative log base 2 of negative x. Awesome. All right. So let's take a look at page 609. Now, they use some, funky notation here. This just means this is outside the function, right? This is inside the function. Multiplying is a scalar. Adding or subtracting is a translation, right? So over here, what am I doing? I want to describe this. I am multiplying by 5. It's on the outside, so that is a stretch, right, of 5 vertically. All right? So that means we're going to stretch everything by 5 vertically. So our graph is going to be stretched. Everything's going to be stretched. So first of all, this is 0, 1. So that's now going to be up here, right? Everything becomes stretched. It's a lot. It's not easy to draw these graphs necessarily, but the basic of it is easy to understand. This one should be pretty easy to draw. This is inside, and it's a subtraction of 4. Now remember, horizontal is inside, so this is a shift because I'm adding and subtracting, and it's always the opposite. So instead of left 4, it should be shift right 4. So I'm going to take each point and go to the right 4. 1, 2, 3, 4. All right, I'm going to find another good point. Here's another good point. 1, 2, 3, 4. And then I'm just going to shift it to the right 4. There you have it. All right, I want you to pause the video and just kidding. No, we're going to do this one together. All right, so this is 2 to the x minus 3. Minus 3, that's another shift, but it's outside. What do I mean by the outside? Where is the x? Find the x. That's the inside part. This is not with the x, so it's outside. It's minus 3. That means all of my things are going to drop by 3. Look, this is actually going to change an asymptote, isn't it? So this is actually going to change my asymptote to negative 3. All these points are dropping. 1, 2, 3. 1, 2, 3. So it's coming in here along the asymptote and going up. Nice. All right. What I want you to do is I want you to do these now. This is 10 to the x. All right. I see some multiple things here. I want you to describe all the transformations and try and graph it on your own. All right, I'm going to pause the video now. All right, so what you can see here is I have a vertical stretch of 3. The negative is our vertical reflection. Inside I have left 2 and then minus 1 down 1. All right, so what I did here was I started at 0, 1 because I know my original 10 to the x. If I have x is 0, if x is 0, then I am at the point 0, 1. So I'm going to start with that point, and I'm going to do these reflections. So the very first thing, stretch of 3, vertical, so 1 times 3. Now my point at 0, 1. Now, by the way, their graph was wrong. Now that point is at 0, 3. Now I'm going to do the next thing. It says a vertical reflection, so that changes it to a negative. So now it's at 0, negative 3. All right, I would be down here, 0, negative 3. Then I say go left 2. So I'm going to take this point and go left 2. That'd be 0, minus 2, negative 2. So now my point is at negative 2, negative 3. And then it says down 1. So negative 2, negative 4. So that down 1, now remember, that's a asymptote. Our asymptote actually changes here. It's crazy. All right, so negative 2, negative 4. All right, that is kind of our like vertex. It's not a vertex, but that's where we're starting at. It's going to come in here, much like that. Boom. All right, so that's how I did mine. Okay, if I do the same thing over here, I start at 0, 1. I'm going to do a vertical stretch of 2. So 1 times 2 is 2. Then I'm going to go, I have the x minus 1, so the opposite of minus 1 is right 1. So I'm going to go add 1 to that, so now I'm at 1, comma 2. And I'm up 3, so my vertical is up 3, so that would be 1, comma 5. All right? So 1, comma 5 is here. Basically off the screen here. But we can also understand I'm shifting my asymptote up 3. So here is, or somewhere around here is 3. Maybe I missed that. But so our graph is going to come in through here, much like that. All right? All right, so let's take a look here on the next page, on page 611. We're doing the same thing, just with logs. Ugh. So this is log base 10, right? Because I don't have it written. So log base 10 graph looks like this. My asymptote, ooh, go back. Hey, what changes here? When I shift stuff, when I do all this stuff, did my domain change? My domain does not change. Does my range change? Yeah, sometimes that range changes, right? If I have a vertical stretch, it changes because now I don't go up forever. If I have a vertical shift, it goes up and down. That changes my my range. So my exponentials, my range changes, but my domain does not. That brings us to logarithms. Remember the inverse. So we should be thinking that if the range changed on the other one, this should be the domain. And in fact, it is going to change, right? It could change. We have that asymptote at 0. All right. So what is this going to be? This is going to be a vertical stretch of 3. All right. Now, these are kind of hard to stretch. I'm not going to lie to you. But here's our good point. Remember, it's 0, 1. I know that looks a little off. 0, 1, or excuse me, 1, comma 0. All right. So now another good point would be 10, comma 1. That means it's going to take me 10 over to get up 1, right? So that stretch would actually be 10, comma 3, which would be up here. So my new graph would go up a little bit faster than my other one. All right. This one, my whole graph is going to shift where? To the right 3, correct? Right 3, because it's an inside shift. So I'm going to actually just do this. I'm going to move my asymptote. And we talked about this. If exponentials, the range changes, now we see our domain changing, right? So nothing else changed. I'm going to move my graph, and it should be pretty much exactly the exact same thing. All right? Let's try the bottom one. So down here, I'm going to move every point down 3. So my domain is not changing on this one, but every point is going to move down 3. So 1, 2, 3. Let's find another good point. You know, I mean, these are not good. 1, 2, 3. It basically looks like this, where everything's just shifted down 3. All right. What I want you to do is I want you to do the same thing we talked about here. Try it on 5, A and B. Write it down, and then try to find the graphs on your own. All right, welcome back. So this one, I have a vertical stretch of 4. I go to the right 1, and I'm going up 3. All right. So the first thing I would say is this. When I draw this, I'm going to actually look at doing the asymptote first. So I know that I'm going to go right 1. So I'm going to draw my asymptote, because I now know that my domain can change when I do these, right? All right, so I start here. I rewrote this as 2 to the y equals x, the base one. All right, and I'm going to find a point. So when I plug in y is 1, I got 2. So I have a point of 2, comma 1. Now, again, they screwed up, but we're going to translate that graph. All right, so the first thing is vertical stretch of 4. Vertical is a y, so stretch it by 4. Now I'm at 2, comma 4. I'm going to go to the right 1, so that's an x. 2 plus 1 is 3, so now I'm at 3, 4. And then I'm going to go up 3, so that's 3, 7. So I'm going to go up 3, up 7, somewhere here, all right? And, I mean, the graph is going to look very similar. It's just going to go up 3, 7. It's going to flatline. Well, no, it's going to stretch, right? So I'm stretching it a bit. When I stretch these, and instead of it being flat like this, it's going to go up a little bit faster, isn't it? All right. So let's do this one. I have a vertical reflection. I have left 3. I have down 4. Our first point is the same. So when I'm at x is 2, I'm at y is 1. All right. So now I'm going to have a vertical reflection. So now I'm at 2, negative 1. My y vertically reflects. I went left 3, so 2 minus 3 is negative 1, negative 1, and down 4. So my new point would be at negative 1, negative 5. That's kind of my reference point. That's what I'm going to use. I'm going to do my asymptote first, so I know where to approach. All right. I know that I'm at negative 1, negative 5, somewhere in here. And I know it's flipped, so you got to remember that. So it's going to come in here like this, and then be something like that. All right? All righty. All right, let's go to page 614. And we're going to actually look at this and write the changes, all right? So f of x is our original. So what do I do to f of x to make it g of x? Well, the first thing I know, this is an exponential, but we're not worried about that. The first thing I know is it's a vertical reflection, right? So I'm going to do the opposite of my f of x for sure, at a minimum. All right. So now I need to look at some points. So looks like these points are one apart, one apart, one apart, one apart. So I'm not like multiplying it by anything. That's good. But it does look like it moves, right? It looks like it moved 2 to the right. So that would be x minus 2 because the inside is horizontal and it's the opposite of what I think. All right. Let's do part B here. Let's do part B. That's fine. All right. So f of x again is here. Now I notice it drops 2. So that is at 2, 1, 2. Looks like it drops 2. All right. And let's see the change here. So over 1, up 1. Now down here it's over 1, up 2. So I actually am multiplying that gap by 2, right? So I'm vertically going to multiply by 2. I'm not moving it to the right or left. My x points stayed exactly the same, didn't they? All right. And then I actually just, what did I do here? It looks like I subtracted by 2 as well, minus 2. All right? So now I want you to try these two on your own down here. All right, now they're logs, but again, we're going to write them in terms of f of x. What am I doing to f of x to get them to change? All right, go for it. All right, so this one, the points move they just move left 5 units. 1, 2, 3, 4, 5 units. So that's just a f of x plus 5. Over here, it's a little bit trickier. This should be an 8 here, sorry. But I noticed the vertical change in these points was 2, and the vertical change of these points was 8. So I multiplied that by 4. That's a new gap of 4. So my vertical dilation or my vertical stretch is 4, so I'm going to do 4 times the original function. All right? All right, let's go to page 615. All right, we're going to talk about what shifts happen and then rewrite it. So, for example, this is going to be a vertical stretch, right, of a half, or dilation, maybe you want to say. And then we're going to go left 3. All right, so this is an exponential equation is what they say. So 2 to the x, let's do it. So this is going to be t of x is going to equal 0.5 times 2 to the x plus 3. That would be that. All right, down here, e to the x. So now I have a vertical reflection and a vertical translation or shift of down 1. So this is going to be negative e to the x minus 1. So t of x here would equal negative e of x minus 1. All right. Save that one for you to do in a second. Let's do a log one down here. Now this is a log base 10. So this is a vertical stretch or vertical dilation of 3 and a vertical shift or vertical translation up 4. So now I'm going to have 3 times log x plus 4. Natural log, remember natural log is just log base e. So the natural log, so now this is going to be a horizontal reflection and down 1. So we have t of x equals the natural log of negative x minus 1. All right. Take just a minute and come up with the 2 new equations for C of part 3 and part 4. Go. All right, so let's take a look on page 617. This is going to be kind of weird, but what we're going to do here is we're going to start with f of x, which is 2 to the x, and g of x, which is the inverse, log 2 of x. And you can see those graphs here. What we're going to do is we're going to transform f of x with this transformation. So let's do that. So this means I'm going to move every point left 4. So 1, 2, 3, let's see, 1, 2, 3, 4. So now this is negative 2, 4. 1, 2, 3, 4. This is now negative 3, 2, and so on. 1, 2, 3, 4. This is now negative 4, comma 1. All right. Now let's use these points, these new points. I mean, we could keep going. We obviously don't need to, right? We could keep going. Let's graph the inverse. Remember, inverse, x becomes y becomes x. So negative 2, 4 is going to become 4, negative 2, 4, negative 2. Negative 3, 2 is going to become 2, negative 3, 2, negative 3. And negative 4, 1 is going to become 1, negative 4. 1, negative 4. So now let's take a look and see what happens to that graph. What happened here? The transformation on the original graph, we all agreed, left 4, right? So what does it do to the transformation on g of x? Well, it actually goes down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. It goes down 4. Whoa. Remember, x becomes y. X left becomes y down. That should make sense, right? All right, let's take a look at another one. All right. So in this case, I'm going to take my function and move it up 5 points. So I'm not moving all of these. So this is 1, 2, 3, 4, 5. So now that is 0, 6. So we'll have one at 6, 0. And then we have, this is up 1, 2, 3, 4, 5. That's at 1, comma 7. So we're going to have one at 7, comma 1. Right? And then we have, this is 1, 2, 3, 4, 5. And that is 2, comma 9. And so we should have one at 9, comma 2. And our graph should look a little bit something like this, right? That's pretty terrible. All right. But what happens here? This point shifts 1, 2, 3, 4, 5. Ooh, so our transformation on f of x was up 5 units. And what happened on our g of x? It's going to be not up, but y becomes x, right 5 units. All right, so when we have our graph, its inverse, it does similar things, right? Let's try another one. Let's just try and see if we can figure this out. So this is going to be right 3 and up 6, right? Right 3, up 6. That's what our transformation on f of x is. So what should our transformation be down here? So right 3 would be up 3 because x becomes y. And up 6, y becomes x, right 6. Let's try it. So this is right 3. So 1, 2, 3. And then up 6. 1, 2, 3, 4, 5, 6. So that point is 3, comma 7. So we should have a point at 7, comma 1, 2, 3. All right, let's see how we can get there. Let's see. 1, 2, 3, 4, 5, 6 to the right. Yep. 1, 2, 3, up 3. Now we know we don't have to do it the long way. We can take our x, make it our y, our x, right? Should be fairly easy. Of course, they're going to give us a stupid one. A stupid one meaning the same number twice. So this is going to say left 1 and up 1. So that means my x becomes my y, down 1, and my y becomes my x, right 1. Okay? All right, now on the next page, on page 619, we have some generalizations here. So this just says, what happens on my x? When I am adding something on the inside, that's a horizontal shift, right? So it's going to go to the left because it's opposite. So left, c units. All right, so we now know its effect on its inverse is x becomes y, so it would be down, because left and down, c units. Here I would go right, c units, because it's the opposite. X becomes y, right is like up, c units. If my original function goes up d units, y becomes x, right, d units. All right? Down d units becomes y becomes x, left d units. All right? So I want you to do 3. I'll do one with you. Consider the original function. All right? Write an equation for the inverse. All right, so let's do that. Let's try that one. So this is, originally it's going to go right 1. So that means our inverse has to go up 1, right? So I'm going to write that as the inverse of x plus 1. All right, so this is down 2. So down 2 means left 2, right? So that means my inverse is going to go to the left 2. All right, I'm going to pause it. I want you to do C and D all by yourself. All right, so over here I have it going left 5, left x becomes y, which is a down 5. So my inverse of x, minus 5. Here I am going to the right 4 and up 3. Right becomes down. That ain't right. Right becomes up 4. Man, screwed that up. Up 4. All right. And then up 3 becomes right 3. So it's going to be the inverse of x minus 3 plus 4. There you have it. All right. Your bookwork is going to be on page 625 and 626. Numbers 1, 2, 3, 4. All right. Do all those. 4 may be a little tricky. I'm not sure. Do your best. Ask for help. That's what we do here. All right. More questions you ask, the more you learn. The more you learn, the better you do. All that fun stuff. All right. We're here to help you. Make sure you ask lots of questions. So see you next time. Peace out.